Whole numbers are relatively easy to plot, but you need to make sure that each one of these tick marks represent a value of 1. In other words, if we start at 0 and we count to the right, we want to make sure that this next tick mark represents 1. So we literally just start counting 0, 1, 2, 3, 4, and 5. Because it matches up with what's already written, we know that each one of these tick marks represents a value of 1. So if we're plotting -7, we would start at 0 and count 7 times to the left because it's negative. So we would count 1, 2, 3, 4, 5, 6, and 7. So -7 would be right here. For -2, we would again start at 0 and move 2 points to the left. So 0, 1, 2, and we would end up right here. And for 12, we would start at 0 and move 12 times to the right. So 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and 12. Plotting fractions is a bit more involved than plotting whole numbers. We always want this number at the bottom of the fraction to represent the number of spaces or the number of tick marks between each value. So for example, if we start at 0 and we count to the right until we hit this 1, we would count 1, 2, 3, 4 tick marks or 4 spaces between the 0 and the 1. That should match up with this denominator, and it matches up with both of these, which makes this problem relatively simple. Since we know the denominator matches up with the number of tick marks, we can just focus on the numerators, and the numerators will tell us how many spaces to count to the left or to the right starting at 0. So for this first fraction, I want us to count 3 times to the left out of those 4 spaces. So if we start at 0, we're going to count 1, 2, 3. This would be -3 out of the 4 spaces. To plot 7 over 4, we would start at 0 again, and we would count 1, 2, 3, 4, 5, 6, 7. So this would be 7 over 4. Something worth pointing out is that this fraction isn't necessarily less than 1. Like if we notice when I counted to 4, 1, 2, 3, 4, I was already at the whole number 1, but I had to keep going just because the number was 7. So 4, 5, 6, 7, and we landed right there. This problem is a bit more involved than some of the other questions. So the first thing when plotting fractions is to make sure that the number of spaces between each number matches up with these denominators. In other words, let's say I count from 0 to 1. From 0 to 1, there are 1, 2, 3, 4, 5, 6 tick marks to reach the number 1. That means that for both of these fractions, I want these denominators to be the number 6. The problem is this second denominator has a 3 at the bottom. So we need to rewrite this fraction. We need to change this 3 from the denominator into a 6. The way to do that is similar to finding a common denominator. In other words, what can we multiply this 3 by to turn it into a 6? Well, we could multiply it by 2, because 3 times 2 would give me a 6. But because we don't want to affect the actual value of the fraction, what we do to the bottom of the fraction, we do to the top. So we need to multiply the top by 2 as well. So 5 times 2 would give me 10. This would leave me with a fraction of 10 over 6. And 10 over 6 is what we're going to use to plot this point, to plot this fraction of 5 over 3. So it turns out that 5 over 3 is equal to 10 over 6. So we're not going to look at 5 over 3 anymore. Instead, we're going to focus on graphing 10 over 6 and graphing -2 and 1/6. So we'll start off with -2 and 1/6. This is a mixed number, and what that means is they give us a whole number. They give us a -2, and that's basically going to be our starting position. So instead of starting at 0, we want to start all the way over here. We want to start at -2. And from here, we're going to move either to the left or to the right by 1/6. Now the value is negative, so that negative tells us to move to the left. by 1 out of the 6 spaces. So from -2, we move 1 time to the left and we end up right here. So this point would be -2 and 1/6. So we're done graphing that. Now we can move on to the other fraction. So you turn 5/3 into 10/6, and 10/6 is what I want to graph, or what I want to plot. So starting at 0, we're going to move 10 times to the right because this is positive. So from 0, we count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And we would end up right here at 10/6 or 5/3. One last example is plotting these two rational numbers. So again, the first thing I want to do is make sure that the number of spaces between each number matches up with these denominators. So from 0 to 1, I'm going to count the number of spaces. 1, 2, 3, 4, 5, and 6 to actually reach the number 1. So both of these numbers in the denominator should be a 6. That means 1 and 5, 6, this one's okay, we can leave it alone. But we want to turn this 3 into a 6 for this other number. How do we turn a 3 into a 6? We do that by multiplying it by 2. So we multiply both the bottom and the top by 2. This ends up leaving me with -2, and 1 times 2 gives me 2, 3 times 2 gives me 6. So we end up with -2 and 2, 6, and that's the number that we want to plot. So if we start at -2, we would start here. Then we would count 2 out of 6 spaces to the left. So starting at -2, we count 1, 2 points to the left, and we end up right here. So this is -2 and 2, 6, or we can think of it as the original number of -2 and 1/3. And to plot the last rational number, we start at 1 and we count 5 places to the right. So we start at 1, and out of these 6 spaces, we count 1, 2, 3, 4, 5. And our rational number would end up right here. This is 1 and 5, 6.